back now for another topic. I'll just take my Milo energy drink. Very hot. Oh my gosh. Guys, this is really my weakness. I kept on talking and then the hotness of the drink will be lost. Due to heat transfer, thermal equilibrium inside the room, the coldness inside the room, right? So this is one basic example of heat transfer. Temperature, transmission from hot to cold, cold to hot, something like that. Okay? Oh my gosh, and I keep on talking and then, oh my gosh, my energy drink will become cold later. But I just want that to happen. Let's treat this stuff. Okay, but take a deep breath. We'll proceed to this time problem solving. Okay. Not very difficult, guys. Only very simple. That's it. Very simple. Just requires chucho. Asan the problem? Actually, I've done this vlog yesterday, but I forgot this one. Oh my gosh! Dealing with hydrogen. Okay, hydrogen is one of the most important elements in the universe. It is the lightest element in the universe. Hydrogen. So, pinakagaan. Okay? Lightest element in the universe. Second is helium. Okay? Hydrogen is an element found in the sun, aside from helium, right? Oh my gosh. Really? Who discovered hydrogen? Anybody? I think it's gonna be Henry Cavendish discovered oxygen. The last name is Mr. Cavendish, right? Because Rutherford discovered proton, right? It's gonna be proton, right? Okay, and then James Chadwick discovered neutron, and J.J. Thomson discovered electron, right? So it's gonna be Henry Cavendish because oxygen is Jules Priestley, right? Who discovered oxygen. And oxygen also is the most abundant element in the planet Earth, but not in the universe. Okay, in the Earth only, in the land, like that. Okay, but this hydrogen is in the universe talaga siya. Even in the outer space, in the galaxy, in the Milky Way, like that. Okay, the planetary science, right? The study of planetary science and time and space, and then the black body, radiation, and physics also. Uy, init pa kaya akong Milo. Pero kung state sa kuwan. Problem. Chop. State na lang po. Okay, this one. Can you read this one? It's very clear or not? I have to put this in a pencil pen. So, anyway, you can just listen to this. Hydrogen gas is maintained at 3 bars and 1 bar on opposite sides. Wow. Of a plastic membrane. Oh, membrane, which is 0.3 millimeter thick. Thick meaning thickness. The temperature is 25 degrees Celsius, and the binary diffusion of hydrogen in the plastic sheet is 8.7 times 10 to the negative 8. Oh my God. Square meter per second. Oh. The solubility of hydrogen in the membrane is 1.5 times 10 to the negative 3 kilomoles, oh my gosh, per cubic meter bar. That's what I told you. Solubility is mentioned here, not the concentration. Okay, but it's just the same meaning. What is the mass diffusive flux of hydrogen through the membrane? Oh my gosh, it looks like difficult, right? This is Chemical Engineering Board Examination, year November 1991. Okay, in the Philippines. Chemical Engineering Board Examination, November 1991. Let's check this out. Actually, it's really difficult to look at first because the unit is very strange. Oh my gosh. Solubility is 1.5 times 10 to the negative 3 kilomole per cubic meter. What's this? I don't encounter a solubility and concentration that have a pressure at the denominator. Okay, so how can we do this? Wait, I will drink the Milo first. Charot! It looks like interesting, right? There's a pressure in the denominator in the unit of solubility and concentration. Since we know concentration is not only molar, molality, normality, like this. Oh my gosh. But I'll give you a hint and clue. This is the conversion factor. So this is the power now of conversion. Since we know that this is very rare, oh my gosh, what can I do for this? Then conversion will do. And then you have the basis of calculation. And somewhere cancels out unit, then bingo, as long as the unit will become a concentration somewhere along your conversion, then that is really the value of your solubility. Don't be afraid that it is not a unit of solubility and concentration. You still have another option. The last option will be conversion. Okay? Muna pirmi ha. Basta dili gid gani siya madala sa formula or sa inyo na memorized. Ganun na yan. Conversion. Ganon. So you applied conversion factors already. Patulong kasi cancel na sa numerator. Mga magdua-dua ka ba? Yung alam siya ng mga engineering students, you should have a wild imagination. Okay? Yung yung kanon ba nga, tukion jud mo. You have to dig it up. Parang ganon. You will never stop if you will not get it. Something like that. You can never sleep if you will not solve that kind of problem. So that's one quality of an engineering student or an engineer. You will never sleep if you will not get that problem. Especially if it involves numbers. Okay, and equations like this, formulas. Okay, it will really bother you. Really, okay? So that mentality and cultural attitude, that is a positive attitude of engineering student. Not only limited for engineering student, also for other students. That most of the time engineering, because engineering have a lot of numbers, mathematics. Okay, there's also BS mathematics, right? Their major is also all about math, and not only limited to engineering, right? So, it's gonna be like this. Tapos nakakainit pa kayo kuan, Milo. So, atong hinumduman guys nga, ang kani siyang, 8.7 times 10 to negative 8 meters squared per second. Okay, if we speak about diffusion coefficient, bear this in your mind, that it is the area over the time. Right? So remember this always. This is a basic concept of diffusion. So like that, there must be an area and a time. Okay? Then since it is a coefficient, that is the ratio of the area over the time. Okay? So klaro kaya ang unit to? Squared meter over second. So area over time. Kung sa Bisaya pa imo siya hubaron ba, hubaron nimo. Mo din siya, mumaoro sa siya ang problem solving. Hubaron jud nimo ba ang tagsa-tagsa kakuan, tukion jud nimo. Ikaw man imong tuki, inanay din nimo masabtan. You got the point? Okay. Hydrogen. What is the molecular weight of hydrogen? Anybody? Anybody chemical engineering student right now in front of me? What is the molecular weight or atomic weight of hydrogen? Since we know hydrogen is the lightest element in the universe, discovered by Mr. Henry Cavendish. So what is the molecular weight? Okay, the molecular weight, ako na yung answer. The atomic weight of hydrogen is 1.08 grams per atom. Okay, atom because it's single element only. It's not a compound. I will say also grams if it is water. A combination of hydrogen atom plus oxygen atom. But in here, only hydrogen, so I say gram per atom. Not gram per, but actually it's the same. It has the same thing, but I'm only talking to the precise and technical way of saying it. Okay, I'm teaching you the correct and the most precise and technical definition of this hydrogen. Because hydrogen is a single element. That is not molecular weight. Okay, that is atomic weight. Okay? You get the point? Single element naman siya. Ngayon, diba? Uy, single element na siya. So, atomic weight. Okay? Or atomic mass. Okay, it's just the same. Okay? Okay. Atong tagsa-tagsa ang huban. Charot. Hindi na naman tayo. Anyway, I did like this. Okay? Because when I know, I love heat transfer, not this topic. But we cannot escape, if we're studying chemical engineering, we cannot escape really study this one. Okay? Mapugos juga study bisa di kaganahan. Okay? Makalagot, di ko ganahan yung mass transfer because a lot of, mga membrane separation, ang heat transfer nito tugod kay siya. Ang sa for me only, okay? I love to solve heat transfer problems rather than mass transfer problem solving. It doesn't mean that I don't know, it's just I don't like, okay? You got the point? Kaya anak yan na siya, every student has its own masterpiece or area or subjects that you are, you excel well. Your strength ba? So, mo na siya ang akong strength sa chemical engineering, ang heat transfer, ang kaning chemical reaction kinetics. Chemical reactions. I love chemical reaction. Okay? Chemical reaction engineering. Okay? How to make nuclear reactor, how to design chemical reactor, or a nuclear power plant, something like that. So that's the study of chemical reaction kinetics. Okay, chemical reaction engineering. Okay, so I love that. And also this heat transfer. But this mass transfer. See, what time mo? Okay, let's do this. Okay, hydrogen. Kuan siya. 3 bar. Okay, 3 bar and 1 bar on opposite side. So magdulod sa tag plastic membrane. Nasa ng plastic membrane. Okay. So if we're dealing here with membrane, guys, this is automatically membrane separation process. Okay? If we talk about membrane, the word membrane ba? So that is membrane separation processes. This is an example. Okay? And there's a diffusion through that membrane. Okay? From the inner to the outer and goes back again to the outer to the inner. So diffusion. Okay, this is gonna be our plastic. Muna siya atong plastic membrane. Let's see, example this one. Okay, now the inlet pressure will be 3 bar. Here, so let's say component A. Okay, component A, PA, right? PA, pressure A is equals to 3 bar. Okay, 3 bars, plural. Okay, pressure at the outlet will be 1 bar. Pressure B is equals to 1 bar. O, ganan. No problem because only hydrogen is entering in the membrane separation process. This is not too complicated, ha? So, the more problem is there are 2 chemicals interacted in the membrane separation process that will become a problem. But this only hydrogen will pass only this plastic membrane. That is not an issue. Okay, it's only single component will pass in the membrane. Let's just do a chuva chuchu and then you can get the answer. Okay, but if you try to consider so many chemicals will go in the membrane, that will become a problem. You'll do it individually. Okay, but here only single reagent siya. Okay, so hydrogen. And then thickness mo ni siya sa plastic. Thickness is 0.3 millimeter. Ano siya? Okay. 0.3 millimeter. Okay, now the temperature is 25 degrees Celsius. 25 degrees Celsius. Bitik na siya, guys, ha? This is only a trick, T-R-I-C-K. The temperature is only a trick because the temperature here will not matter because this is not heat transfer. Okay, our driving force here is the concentration gradient. The temperature mentioned only here is that we can have this quantities at this particular temperature, but this will not be used in the actual computation in the substitution of the formulas. You get the point? Muna siya natabo. Okay? So, our is 0.7 negative 8 meters per second. So, that is diffusion coefficient. Okay? So, since only one component, capital A, so we need to put dA. So, that is diffusion coefficient or mass diffusivity. Ganon. Is equals to 8.7 times 10 to the negative 8 squared meter per second. Oh my gosh! Yes. Okay? At yung kalibog ka na yung diffusion coefficient kasi maglibog mo sa katong acceleration, kinarabog po siya yung meter o second, ang velocity, sa ba to siya, ang speed. So, at yung kalibog na area kinapermi ang numerator sa diffusion. Okay? Not, kaya katong chupa-chucho sa mga motion sa physics, di man siya exponent ang numerator. Okay? So, mo yung timaan. Okay? Okay. Kasi mo kalit kaibo mo na, nalagyan yung area sa taas. Mga ganon. Kaloka. Okay. The solubility of hydrogen in the membrane is 1.5 times 10 to negative 3 kilomole. Guys, kaning kilomole, bitik na po ni siya. Mahadlok na kano, kay kilo siya. So, ay yung kahadlok kay bit. As is, regular siya ang kilomole. Kaya maura masad na siya sa mole. Okay? Di kilo lang siya. Asayang kuan, ang problem. Pero, it doesn't matter. Okay? Later, we can convert or as is, like that. Okay? So, what is the mass diffusive flux? Chararat. So, mass diffusive flux. Wow, bongga. And you should remember also, class, in transport phenomena, the term flux is very important, ha? If we mean about flux, mungkin na siya ito mga mass flux. Okay, momentum flux. Okay, heat flux. Okay, kung heat transfer gani guys, heat flux na yun. Momentum transfer, momentum flux. And then for the mass transfer, mass flux, muna siya itong i-compute. Mass flux. Yeah, kung ang bagay mo siya diffusive, kay diffusion muna ang hitabo. So, diffusive mass flux. Okay, so don't be afraid of the adjective diffusive describing the type of flux we have. Okay, it's just the same with mass flux or diffusive mass flux. Okay, kanang terminology sa may makapadaog kanang confuse students. Pero ako dili ko maglibog. Okay, but you should remember it doesn't matter. Okay, as long as that is the term we are referring to. Okay. Okay, going back. So mass flux is equal to number of moles. So mass flux, lagi din siya number of moles per me, di ba? Kaya, di ba para itong molar mass? Molar mass is equal to the mass over the number of moles. Most din siya. Pero in terms, lagi siya sa flux. So mass flux component A is equal to the mass of this hydrogen. Because hydrogen will enter. Okay? So, hydrogen. Okay? So, this is gonna be hydrogen, no? So, number of moles of hydrogen. So, ang Na diri ari, muna na siya ang molar mass. Okay? Molar mass. Yung say, malibog ka no, di ba? Pero sige na lang, ito na ang tuson. Charot! Kaloka. Okay? So, this is, di ba na kay molar mass? So, actually, this is molar mass flux, kintahay. Pero, i-shortcut siya as mass flux. Understood na siya ngayon, naging siya. Kaloka. Is equals to mass of the hydrogen over the number of moles of hydrogen. Okay. Ganun siya, no? Since mass flux ang gipangayo, so ang mass flux niya, NH imong kwaon. So, in algebra, cross multiplication. So, NH is equals to molar mass A. Molar mass A is equals to the number of moles of A. Muna na siya itong equation 1. Equation 1 will be the mass flux of hydrogen is equal to the molar mass or atomic mass of hydrogen times the N. Okay, and number of moles, something like that. Okay, or number of atom. Okay, usa ra man ang hydrogen. Okay. Now, unsa pa jud? So, wala siya. Okay. Now, natin concentrate. The hydrogen of them is 1.5 times 600 kilomole cubic meter per bar. So, this is to be understood, guys, that the concentration that will pass at a pressure of 3 bar will be just equal to the solubility that will pass in the outside the outlet, outside the membrane of the plastic membrane. Because in the problem, it was not mentioned the change in concentration. So the concentration is constant somewhere along the way from the initial, before passing the plastic membrane, and also it will become the concentration after passing the plastic membrane. You got a point? Okay. So, now, since there is a denominator of bar, and we have also the bar in the inlet, which is 3 bar, then it's very easy, conversion factor, we have to multiply that by 3 bar, so that we can cancel the bar in the denominator of this 1.5 times 10 to the negative 3 kilomoles, para solubility or unit siya sa concentration na lang siya. Get the point? Okay? Muna siya ang bitik nga par. Okay? Bitik ang katapulan kayo mo convert. Okay, kay muwa jud. Okay? So, solubility in the inlet, ha? So, say PIA. O, ganon. So, I could say also as capital C concentration, CHI. This is hydrogen, subscript. So, capital C concentration, the first letter of concentration, and H is the first letter of hydrogen. And I is the first letter of initial. So, CHI. Okay. CHI is equal to 1.5 times 10 to the negative 3 kilomole cubic meter bar times 3 bar. Okay. So, cancel. So, we have now the initial concentration. Okay, pila man na siya. Calculator, please. Charot. Basta na exponents ato dyan calculator. Okay, guys? Adyo lang itong kalimtan ang calculator. Ay, nabuang na. Diba? Calculator. O dito ka solve na ito. May calculator. Habili na calculator. Exponent, magod siya, guys. Dito siya calculator. Sino ito akong calculator? Ganun. Kung nabili ng calculator, ay takasolve ani. Alam mo kayo cellphone, no? Sige, gamitin na itong cellphone. Okay. So 1.5, tagamay naman siya, guys. So mahugi siya 0.0015. Kay negative 3 man siya. Right? Dali ka na siya, iso. Okay. 0.0015. Okay. So 0.0015. 1, 2, 3. Kay negative 3, move the decimal places to the right. Right? Sakto ba siya? Negative, yes. So, 0.0015 times 3. Ano na lang siya? Ano siya ang concentration? Kaloka. Okay. So, we have this one. Calculator, please. Phone na lang akong igamit, guys. 0.0015 times 3 is equals to 0.0045 kilomole per cubic meter. 0.0045 kilomole cubic meter net siya. So we have the initial concentration of hydrogen that will pass to the plastic membrane. So this is 0.0045 kilomole per cubic cubic meter. Okay, and second would still using the same solubility because constant. Okay, CHF. Okay, CHF is equals to, again, 1.5 times 10 to the negative 3 kilomole cubic meter times bar times 1. Cancels out. 1 raman siya. Automatic ni siya nga mo ragyapon. So 0.0015 kilomole per cubic meter. Okay. So we have now the final concentration. Okay. You have the final concentration. And what will be able to do for this in this manner? How can we do this? Okay. Saan man yung pag-compute ano niya sa iyang mass flux? The mass flux is here. The formula, right? So, Na molar mass times Na. So, dili na kayo kinamang kay molar mass hydrogen. Okay? Like that. So, gamitan ninyo katong formula sa mass transfer. Nga maingon ka nga resistance of the mass transfer is equals to the length over the diffusion coefficient. You get the point? Diffusion coefficient. Gamitan ninyo mo siya kaya naman coefficient diffusion given, right? Ano siyang gamiton? Okay. So, resistance is equals to the length or thickness, marami po pasabot ani, times the diffusion coefficient of hydrogen. Okay. Na kay thickness na length, nasa kay diffusion na given na 8.7. So, makuha na ninyo dito ang iyang resistance. You got the point? Okay. So, iyang length, wa siya gilid sa millimeter. Wa siya gilid sa meter. We need to convert millimeter to meter. How many millimeter in 1 meter? Elementary level of conversion. 1 meter, how many millimeters? That is 1,000. Okay, so divide directly, right? So 0.3 millimeter divided by 1,000 millimeter. How can we do that? So 0. Mga zero, saan na siya i-move, no? Pero let's just use the calculator to make it safe, ha? Okay. So, 0.00, chararat. Guys, naluloka. 0.003, di ba? Wait, guys, ha? Lubat na mo eh. Huwag yung swerte, lubat should ay, in fairness. Ano ka? Wala dyan. Wait guys ha. Okay. Ay, naloka ako. Hello! Andiyan pa ba kayo? Mga friends? Nagkakaon siya kukuan. Chikinini. Wow. Okay? Resistance is equal to the thickness over the diffusion coefficient. Now let's convert 0.3 millimeter to meter. How much is that? Okay, actually it's easy to convert, but I have to use the calculator to make it safe. Okay, 0.3. Okay, 0.3 divided by 1,000. So it's gonna be 0.0003, triple zeros. Oh my gosh. So 0.0003. This is meter. Diffusion coefficient here in the problem is pila siya? Gosh. Too much paper. Malibo ko sa dagang ipapil. In fairness. pwede ma-memorize ang given mo. Nakugot ang given. Gugot pa sa lukot. Kami na. It's here. Okay. Diffusion coefficient is 8.7 times 10 to the negative 8. Okay. 8.7 times 10 to the negative 8 meters squared per second. Oh, how can I do this? I have no calculator. Because there's an exponent. Right? There's an exponent. How can we do this? Oh my gosh. I have to surrender. Right? We cannot do this having a higher exponent, right? We cannot do this by memorizing the values. So, okay. Nakakaloka. Hindi na ito mga kwan masolve. Okay, wala ito nabilig. Okay. So let's just assume na natin R. Okay, I will just put this R minimum ha. R minimum. Okay, minimum. Lalo nyo yung resistance or else dili siya mo flow. So ganito, why we need a minimum resistance? Because, you know, if there's too much resistance, how can this hydrogen flow in the membrane process? So, common sense, it should be at least having a resistance minimum. That's why, when we get the resistance here by this formula, our resistance will be automatically called as R minimum. Okay, so na natin value, let's say, asterisk 1. Okay, kung ko'y calculator. Okay, asterisk 1. So na natin asterisk 1 nga resistance minimum. And now, we have the formula of the mass reducing flux here that we get a while ago. That is equal to, okay, the mass flux of hydrogen is equal to the atomic mass of hydrogen, right? Atomic mass of hydrogen. So let's say capital N. Okay, then N, number of moles of hydrogen. Ganon. Before going this equation in class, this one, okay, we need to compute the N first because we have the molecular weight already. And it's very easy to compute, right? If we have the molecular weight. You get the point? Okay, so how can we compute for that? Okay, NH, which is the number of moles, is equal to, okay, the concentration. We have the concentration here solved, right? Get the point? Here. Concentration, okay, over the R minimum. So the concentration here, class, is higher concentration to lower concentration. So this is going to be like 0.0045 minus 0.0015. Right? So CHF minus CHI. Okay? Ganun. So NH is equal to CHF minus CHI over R minimum. Now substitute values, CHF 0.045, 0.45, minus 0.00015, and then R minimum na kaning asterisk 1. I will just put asterisk 1. So we have now the NH. Okay. Now let's say NH here asterisk 2. Okay, NH asterisk 2. Makuha na kag-value. Kamu na lang solve sa inyong kuan ko na may calculator. Wala ko scientific calculator. Okay. So NH asterisk 2 na siya. Now, go back again to mass flux is equal to the molecular weight of hydrogen times NH. So, muna na siya. Itong value sa mass flux. Molecular weight of hydrogen, 1.08 grams per mole or atom. Okay, multiplied with this NH. Ang value ano niya, muna na itong mass. Okay? Kilomole minus kilomole, how much? So this is gonna be kilomole cubic meter minus kilomole cubic. It's still kilomole cubic meter. Kilomole cubic meter over R minimum resistance. Muna na siya yung ano na unit ari. So makancel na siya. Okay? So, before going farther, dili pa lang siya, convert na ka. Okay? So, na kay meter, meter cancel. So, ang mabilin gid mo anong higayon na is ano na lang siya, meter per second. Okay? So, ini ka kung ano mo, substitute mo diri ari, imo sa ning dalawa ng meter per second. Okay, then mag-cancel ka. Cancel, ganun. So, ang kanang kilomole, guys, that's kilo man siya. Para mahimo na lang siyang mole, 1,000 siya. So, 1 kilo, okay, 1 times to the 3, right? 1 kilomole is equals to 1,000 mole. So, cancel ang kilomole. Mole cancel also, right? Muna siya. So, ang habilin niya is muna niya siya meter per square second, and then ang grams na diri grams sa kilid. Okay. Now, in ano ganing nga situation nga murag naa pa siya volume, i-multiply din mo siya sa volume diri ari nga given diri ari ha. Okay? You get the point? You get the point? Or i-times mo sa diffusion coefficient. Okay, kaya ang diffusion coefficient, paano to siya? Meter squared per second. Nag-conversion na lang ko. Okay, because if we try to put that in the original equation, there's still units to be left in which it will not agree for the mass. Sometimes, yung anak mo kumusolve ka. If we solve something like this, and then when we reach the final unit, it will never agree, then that means it needs still to be simplified pa, having another conversion factor. Though, may gamit na ka sa formula. Don't stop there. Okay? Kaya kani siya, ino naman niya nga diri nga meter squared second niya. Imo mo na siya i-divide og meter squared second, namang kay diffusion coefficient, ang habilin ang grams na lang. So, muna siyang mass diffusive flux. Diri ari, Okay? Imo siya i-divide ha, kaya mabili na niya ang answer naman, 1.08 times 1,000, it will become grams times squared meter per second, in which na siya sa denominator. Okay, then i-divide mo siya sa diffusion coefficient para matangtang ang squared meter over second, because the unit of diffusion coefficient is also squared meter per second. What's left is the grams. Okay? Inganay nga lang ang mga situation. Ipaslak pa rin mo sa original formula, dili lagyan po siya makuha ang katong yung unit na gipangayo. So that means, napaka-i-times, napaka-i-divide, para masimplify yun siya. Ayaw paghunong. Muna siya yung purpose nga ibutang yun mo ang unit. Okay, not enough nga imo ipang substitute ang mga number kay mumatter mo siya sa last. Okay, you get the point? Mumatter siya sa last, kinapa siya i-times, multiply para lang siya ma-simplify. Muna siya example. Okay? Kaya kung imo muna na ang good guys, kung ngunit na ba nabaya dyan ang divide na ba mo ang order sa coefficient, diba? Yan, mubalik ra po daig ka, diba? Nakakalaw ka. Nakakuha sa point, muna siya ang point. Pwede lang siya mag-LDH ito na yun. Pwede mo ganahan, follow mo dito sa formula. Okay, so pwede masagli siya NH 1.08 grams times LDH ditso. Ako mo sa point, imong gamiton dahan ang resistance looking ka na. Mass flux is equals to the number of moles times resistance minimum. Na imong gamiton na yun ang diffusion coefficient ka, ma-divide na sa division sa ubos. Diba? Pwede mo ko ganahan na kay samok. So ako siyang tagsa-tagsa para I do it individually so that it's easy for me to detect the simplification situation. Kalo ka, situation. Okay, so this is the answer now. 1.08 times 1,000 divided by 8.07. Okay, and then your concentration, okay, i-minus naman ito ang concentration na CHF, CH3, muna na siya yung matabo. Diba? Nakuha ninyo ang point. So, NH is equal to NH mass flux na siya ha. Molar mass 1.08 times NH. So, na-adjust siya yung R minimum. Gamito niyo ang R minimum ha. Kani siya. Makasalay niyo mo, nadaog na yun. So, yung ano siya nga form, Then, style ko na niya class, if you will encounter another problem the same like this, easy for you to answer na talaga siya. If the problem also dealing with this different given na siya, for example, usmod na yun niya, ano rin niya nga, sucrose is maintained at 3 bars and 1 bar, like this, maora siyang kuan, ikaw na bahala, maora na siya pagpaagi niya. Okay? So, that's why it's an advantage that you will do practice every day. Let's say 100 problem solvings every day. It looks like impossible, right? Okay, let's try this. 50 lang. Okay, 50 problem solvings in a day. Okay, so in that way, you will master the situation of the problem solving. That, oh, it's gonna be like this. Oh my God. And then if there are, unusual and rare problems, then that's the time you will use your actual analysis in the actual examination. Then at least, nakapundo na ka o mga daghan jud siya. Okay? Ganda pa kayo, mabaon naman kasagaran, pero medyo difficult, medyo kaya. Okay? You get the point? Yeah, 100 items. Okay, ang difficult siguro ang mga sobra sa napo. Okay? Sobra sa napo, padung 20 ka mo, okay, 80% imo dyan ang kwaon. 20% siguro mo na siya above average or difficult. So di-assure yun, ang katong 80, kwaon dito ni mo, mga sensay ra to. Okay, ang katong 80, labo to itong mga theories, mga concepts, ganun. Then, ang kanyang mga 20% amo na ng mga problem solving. Okay? Yeah. Naglabi ang, let's say, kuan, lisod-lisod kamay. Okay? But madadara. Lisod siya, pero madadara ba? Okay? Muna siya, pero muna mga 20%. Muna nga, di ka makakuha o ka ng taas, nga, makuha 85 jud. Daghan naman siya kailangan ng mura ng above average yung padung sa difficult. Diba? Ay kung ina, perfect din mo ang theory. Diba? Katong 80 na naman ito yung theory. Perfect din mo. What is the main component of the soil? Okay? What mineral is the largest component of the Earth's crust? Ganun. So the answer will be silica or silicon. Okay? So, may baka makakuha din ka ng theory nga, wala ka nag-practice ng theory. Sige lang mag-solve ka adlaw. Nga. Okay, so makuha din ka, butikaw. A, B, C, D, asa mo doon, ganan. So, hindi po itong may theory ka daghan, kaya mo ipangbawi ni mo. Especially kung hindi ka bright of math. Okay? Just like me. Okay, so ang pangbawi dyan ako ang theory. Okay? Ikaw mo sa kugamay sa problem solving average. So, bitad siya. Madagdagan dyan ang puntos. You get the point? Ganon. Okay, that's why ang highest na ko ang chemical engineering. Okay, ang second is physical and chemical principles. Ang third, ang general engineering. So that's really matching my capability because I'm not good in math. And all general engineering are math. See? Di ko siya madaya ba? Okay, mo gudi mong performance in the actual. You get the point? Yeah. Kaya kung ang sa akong paborito, ang katong subject dito sa major. Okay, yung mga chemical engineering dito ba? Masa akong taas? Okay? So, or else, I will be high in the general engineering, something like that, but it's not. That's the lowest score of mine. Okay? Okay. Bugha ka sa kuan, differential equation, advanced engineering mathematics, calculus, mga multi-jud ko. Okay? But at least, magpasaragapin ka. Okay? Ganun. Sharosat, wala kay 70% out of 100. Right? So para dyan ako, no? Ang nakapasa dyan ako ang theory. Really. Para dyan ako ha. Okay, kaya murag, sure dyan ko, murag kasagaran, nakuha dyan ako ang theory. Lagi. Okay? Eh, katong mga upang problem solving sa inyo naman kayo, mga normality ra. Okay, normality 1, normality in 1v1, in 2v2, sa inyo kayo isolve, di ba? Katong mga direct substitution. Katong mga lisod na dyan kayo, mga dito kasabot. At ito sa pinaka-last. na nasakit imong ulo, medyo mo makuha ang formula ba? Buhat agad imong ang formula. Okay, para lang dito makasolve. Ganun. Okay guys, so this problem is Chemical Engineering Board Examination, November 1991. Okay, this mass transfer problems. Ako ka na answer niya ha, later. Huwag sa calculator, good? Okay? Gusto mo na siya ang concept 2. Wow. Okay guys, thank you so much for watching this live streaming. If you like this video, you can comment down below in the comment section. You can subscribe to my channel and you can click the notification bell for some newest updates that I am here. It's your boys. Bye bye. God bless everybody. Bye bye po. Oh my gosh.